Hey, welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be talking about Object-Oriented Programming, or OOP, as it's sometimes abbreviated. What that means is we're going to be talking about classes and how to create them and how to extend them and generally how to handle those kind of things. It's kind of an advanced topic that I've tried to brush up against a couple times throughout the series, and I've avoided because I wanted to do a whole video on it so I could accurately cover everything. It's a big topic, and we're only going to be kind of scratching the surface on a little bit on what you can do. But I think we should just go ahead and get started. If you get confused, please ask questions in the comments or hit me up on Twitter or anything like that. I'd be more than happy to type out pseudocode in the comments or in a tweet to help you out with whatever you're doing. And also, I want to remind you guys about the scripting reference here. It's wonderful, and I know I mentioned it in the first video, but I'm mentioning it again. If you're ever confused, go to the scripting reference and type in a thing. Type in into the search query whatever you're having problems with. I try to stay pretty good about terms, so if you search whatever I'm saying, you should be able to find what you're asking for or looking for. The other thing is that there's another source. It's the MSdn, I think is what it's called. Hang on, I'm gonna look it up really quick. MSdn. Yeah. So this is kind of what it looks like if you go to the website. Not the best thing in the world, but documentation. This is kind of where you're going to want to start looking. If you look up Microsoft C#, you'll get the MSdn reference here. And this is amazing. There's some tutorials here on getting started with C# and all that stuff, but this is also where you can look up classes. So if you look up C# classes, like I did before this, just to kind of see what other people were saying about them. I know about them, but I wanted to know how to describe them to you. You get something that looks like this, which is absolutely invaluable. This is from Microsoft what a class is in C#. I mean, I couldn't describe it any better than it's labeled here. And even some code examples. None of this is going to be Unity specific, keep that in mind, so it's all going to be really kind of high-level stuff, like here's how you define a string and here's how you define a class, and their formatting is going to be a little different than mine because there's different accepted types of formatting for where you are. But basically, if you ever want to know anything about C#, MSdn is a great resource. So is like I said, the scripting reference here, which looks like this. You want to make sure to switch this to C#, and you can search whatever you want. They also have the different types of classes to search between. So anyway, just wanted to start off by saying that because we're going to start to get into some more advanced things here and there in the series. This is kind of the first video of that. Anyway, so getting started, what I've done is I've created a new scene in Unity, and I've called it OOP example. And that's pretty much all I've done. So we're going to start by creating a new folder in the scripts thing, and we're going to call OP. Just because I want to keep these kind of separate from the rest of them. And apologies if you can hear cars or anything like that. I live under a freeway now, so that might creep into the background audio a little. Anyway, so now that we've created a folder, we're going to create a new script, and this is going to be OOP example 1, I don't know, OOP example, sure. We're going to open that up in MonoDevelop, and I'm going to explain what a class is. So we can kind of see it over here while MonoDevelop opens. It's going to take a minute, I think. Try opening it again. Ah, there it goes. Okay, so you can kind of see over here public class, OOP example, mono behavior, all that stuff that we've seen in the previous videos. Best way to think about a class is a group of variables and behaviors. Behaviors being things like functions and things like that, things that we talked about before. So like this go away. There we go. Yeah, it opened 2 of them. Exciting. Anyway, so now that we have this, oh yeah, and I said I was gonna do that. Look at that. Perfect. All right, so this is a function, right? And this is a class. Functions are in classes, and a class is a grouping of variables and behaviors. A function is a behavior, if that makes sense at all. So, as I've described in previous videos, a function is a class is a thing, and then a function is something that thing does. So, if we create a variable here called int myInt, and we make it equal 0, not minus 0, then this variable is within this class. And we kind of already know that. So what I want to do is I want to create a new class. So I kind of already have here, because by creating the C# file, Unity has already created me an OOP example class that I have here. It extends mono behavior, which we'll get to after we create our own class here. We'll get into extending things and what that means. But for the time being, know that by creating a new C# file in Unity and giving it a name, well, I guess not even by giving it a name, it'll create a class anyway. But public class OOP example is a custom class for all intents and purposes. So we've been creating classes this whole time, and you didn't even know. Weird, right? So if we wanted to write a new class, there's really nothing wrong with doing this. Public class OOP vars, and we're gonna open that up just like a function. So you'll notice that I didn't put the semicolon mono behavior down here, because we're not extending anything with this class. We're just creating an empty group, essentially, because again, a class is a group of variables and behaviors. We just wanted to create an empty group. We didn't want it to come with anything, which is what extending does. Again, I'll talk about extending more at the end of the video, but for now, just know that we're creating a class that doesn't have that. So why would we do this? Why would we create a new class, a new group of variables? Well, say, like in the previous example, when I created a class, and I'll actually go ahead and open that up. I think it was under bullet. I don't remember where it was. It might have been under damageable. Yeah, it was. So, It opened another one of these. Why did it open another one of those? That's annoying. Okay, so when we created a new class here called damage info, it had an int and a game object. It had the amount of damage, and it had who sent the damage in a class, so that we could then send that class as a variable to the object here. Right here we created the new variable, a new instance of the class, effectively a new instance of the class, and then as a variable, as a variable called temp, and then we passed that variable through a send message, because we can only send one thing through send message. So that one thing was a group of things. It's kind of like cheating, you know. It's you can only send one thing. Okay, well, here's a box of stuff that is one thing, you know. So that's kind of what we did with this. Now, in our OOP example, which closed because it is the best. My monodevelop's freaking out. It keeps opening new instances of it. So in our OOP example, we're going to create a new thing here, and we're going to call this public int OOP int. It's going to equal 0. Public float OOP float. It's going to equal 1.0. Whoa. Come on. Sorry, apparently my My numlock wasn't on. That's exciting. Was 1.0f. There we go. Yeah. All right. Sorry about that. So we're gonna go public string. If I could type today, which I probably can't. And name this OP string, and we're gonna say it equals that, and because of my numlock flubbing, I missed that. Great. So we have this group of variables here, and now in our OOP example, we can say create a new OOP vars. We're going to say this is going to equal var, or this is going to be named vars, and it's going to equal a new OOP vars. And now this object here contains all three of these variables. So if we wanted to, on start, we can say, hey, vars dot OOP float, int, or string, because those are contained within. So again, vars is just a group of variables, that group of variables being these three. So where you start to see some really interesting things is you can actually put functions inside this class, just like you can in the classes down here. Like start is a function, so, and it's within a class. So why don't we put a class in here? We can say public void set OP int, and we can say OP int equals random dot range, I don't know, 0 to 100. Whoa, 100. And now on start, we can say vars dot set OOP int. Now what that's going to do is it's just going to set our int value to an int somewhere between 0 and 100, and then we can access that later. So for initialization, this can be kind of useful because we can say we have a bunch of randomly generated random variables and things on an object. We can generate all those at runtime with like a well, not at run, well, kind of at runtime, more along the lines of like a public void init function, and then we can put all this stuff in there, if that makes sense at all. So like if we wanted a bunch of startup variables and things, we could do that like this. So that's really useful for setting something up. But something that you'll notice is if I come back to oh, oops, I broke it because I got rid of that variable, or that function. Okay, that should work fine. Yep, cool. So if we create a new game object and we drag and drop our script onto it, we should expect to see a couple things, right? We should expect to see some variables on that script object, and we should expect to well, we should expect to see some variables because we have the whole, these things, right? We have these three variables, and we have that set as a variable here. Oh, we should probably make this public. That way we can see it. So we should expect to see this variable on the object, right? We should, oh, but we don't. And the reason why we don't is because whenever you're creating a custom class that doesn't extend mono behavior, or I believe component as well. Component is another thing you can extend just by typing in component instead. So if we're creating our own custom class that doesn't extend anything, we need to do something special for that to tell Unity that it's okay to put it in the editor window, if that makes sense at all. Now this is kind of getting weird because we've never typed anything outside of a class before. So a heads up there, we're going to be typing the line before public class OOP vars. I'm going to do a open close brackets, and I'm going to type system inside of it. And I'm going to do dot serializable. That's what it is. And I just realized that it shrunk. Oops. I'm very sorry about that. I didn't notice that in all my monodevelop switching around. Anyway. So system.serializable will tell Unity, which is the system, that we can serialize this class, and any serialized classes show up in the inspector window. So if we save this, we come back, we should see our vars class with its 3 variables within. So I know that that's kind of hard to follow, and I know I didn't really explain why this needs to happen. It's because I honestly don't really know. I kind of know. So Unity has a system in place that weeds out what it does and doesn't need to show. So say that you had a public class, but you didn't want it to show up in the editor. Well, then you just don't make it serializable. Easy. But if you do, then you have to. I think it should be the other way around. Everything should be default serializable unless stated otherwise, but I also don't do a lot of intense programming necessarily. Like entire system architectures and things like that. I don't really do much of that, so I'm sure if I did that I'd have a different opinion. But for the time being, this is how you make something show up in the editor. And if you don't want it to show up in the editor, you can get rid of it. And as soon as you get rid of that, it goes away. Go away. There it goes. So it's that easy. And we have our init function. So what's actually really interesting about this is if we start it, that the OOP int will actually turn into a random. Yeah, so there's 40. And if we stop and start it again, there's 99. So it is running that initialization function that we kind of hacked in, because its OOP example is still the class that's on here, up here. So this mono behavior is, because the name of the script object is shared with that class, that's the class that is attached to this object. So for example, if we change this to, instead of OOP example, OOP vars, Unity shouldn't complain too much about that, I don't think. Yeah. And then if we drag, oh, yeah, go away. Yeah, you need to not be on this anymore. Remove component. So then if we put OOP vars on this, it says we can't because it doesn't have. Oh, oops. We don't have an underscore in the name. It will say. It should say that we can. It should let us do that. Oh, okay. Yeah, okay. So can't add it because it doesn't extend from a mono behavior. I believe if we also extend it from component, it'll also work, I think. But yeah, so the reason why that is Unity only likes to put mono behaviors on things because Unity likes to hook into the scripts that are mono behaviors to do things. So that's why we have things like a start, and I'm going to change this back really quick. That's why mono behaviors come with like a start and an update and a start and an update function, and they have other functions that you can attach to them and things like that. That are they're mono behavior functions, right? So these functions down here, the start and update. Unity reaches into mono behavior scripts and tries to call those, and if the script isn't a mono behavior, then it can't attach it. It can't attach it to an object because it's missing pieces that it needs to be able to attach to an object. So we can have the OOP vars as a variable within OOP example, but we can't have OOP vars on an object because it doesn't understand how to put OOP vars onto an object, if that makes sense at all. That's kind of weird, but that's why. Kind of in a nutshell. Anyway, so this is great. We have a class that we've created and we put it as a variable, but this is useful for grouping things together and organization. No doubt, it's fantastic for that, and I use this all the time for that. It's also great for, like I said in the previous example from the last video, for passing variables between objects when you can only pass one thing at a time. So like, here's this entire group of objects because you can only take one thing because I guess, I don't know why. And likewise, you can actually write public void temp func, because why not? You can actually ask to receive OOP vars as a variable, and then you can access that within the function. So you can say temp.oop float int string, whatever you want. You can actually, should be able to, yeah, you can actually call the functions on that as well. But yeah, so you can pass your own classes to yourself, I guess. And I think the one thing you can't do, which I just thought of actually, I don't think I've ever tried to do this, is put a version of itself into itself. This is probably going to be a problem. Wait. Yeah, whatever. Equals new OOP vars. It's probably going to yell at me for that, I imagine. No? Really? Alright. Oh, yeah. Request operation causes stack overflow. You can see that down here. Yeah, it's because every instance of every instance of an OOP vars class had an OOP vars in it, so it was creating an infinite cascading OOP vars problem. That's bad. Don't ever do that. I actually had never tried to do that before, so that was exciting. It may not have seemed like it, but it was. Anyway, so the last thing I kind of want, well, there's two things that I wanted to talk about. Well, I guess they're kind of the same thing. Is inheritance, which we'll talk about why we extend classes like monobehavior and stuff like that. So inheritance is kind of a strange thing. So you have to think about it like a lot of the terms in 3D programs and in programming languages and things like that probably is this way in 3D programs because of programming languages, is a parental hierarchy kind of thing. So you have parent and child, and you have like generations of and what I mean by that is you can have a parent class and a child class, and you can also have sibling classes, which is very strange. So I'm going to go ahead and I'm going to create, oh, well, I didn't really want to close that, but parent example. So I'm going to create that, and it's not going to extend monobehavior. And again, I need to increase the size of that. So it's not going to extend monobehavior, which means that it's not going to have a start or an update function. And what this is going to have on it is this is going to have a public string name, and the name is going to equal parent. And we're also going to have a public, I don't know, int for health. We're going to equal 100 on that. And then we're going to have a public, I don't know, that'll be good for now. No, we'll have a class. We'll have a, like pretend that this is an RPG and we're making a character. Class is going to equal, now normally I would do a class as an enumerator, but I haven't covered enumerators yet, so I'm just saying that strings are not the correct way to do this, but for the purposes of this example it works. And we're going to call this a barbarian, because why not? So we have a new character whose name is Barbarian, and its health is 100, and its level, its level is going to be 1. So this is what we have. So we're creating a character for an RPG, right? So that's fine and dandy, but unless all of our characters are going to be a this kind of thing, so like every character in our game is going to be only ever going to have a name, class, health, and level, then this isn't entirely useful, right? Because then we need to go and create a different class for each type of character we have. So then we need to come up with a public class bard, or well, enemy that's going to have like a public, and it's going to have all this stuff, right? It's going to have all the exact same things, except it's also going to have a like a public int damage variable, right? So it's going to be exactly the same, except for it's going to have another variable, one other variable. So that's kind of a waste of space, right? And people who write programming languages are much smarter than me, and they know this. So instead of doing that, they have this thing called inheritance, where we can say public class. We're going to call this child example, and the child example is going to extend. Wait, why is it being? There we go. Parent example. And I don't know why it's not auto-completing. I'm hoping that it'll actually work. It might not. It seems to. Alright. So, oh, and just so we're consistent, I'm going to put system.serializable at the top of this so we can see it in the engine. And I'm going to start removing things. And actually, I made a big mistake already. This public class needs to be in its own scripting object. So we're going to call this child example. And we're going to put this in there. Sorry about that. There's a reason why, and I will talk about that in a second. Save. Badoom. And we're going to put system. Why is that not? Oh, why is it being crappy? It's being crappy all of a sudden. Alright. So now we have a child example extending parent example, and we have parent example with all these variables. And both of them are serializable. So if we drag the child example onto here, because it's not a mono behavior. So we're going to make the parent example a mono behavior. There we go. Alright. So if we drag the child example onto here, we notice that we get all these same things that are on the parent example. So, okay, sorry, I'm going to backtrack a little bit just to clarify what happened there. So parent example wasn't extending anything. It was just an empty class, just like every other class, like child example, for example. It was just an empty class, and it wouldn't let me attach it to an object because it didn't extend mono behavior, just like we saw earlier. I goofed and forgot to put that in. So we're extending mono behavior there just to make sure, or just so that we can, just so we can attach it to objects. We might end up using some of the mono behavior scripts and stuff, but mostly we just need the hooks to the code that allow it to be attached to objects. So we're extending. Parent example is going to extend mono behavior, which means that it gets all the update and start functions and everything like every other class does. But just know that the main reason I'm doing it at the moment is so that I can throw that scripting object onto an object. And you may be saying to yourself, but wait, you didn't attach parent example, you attached child example. And this is where things get confusing. So just like parent example extends mono behavior and inherits all of its classes and all of its like weird script hooks to be able to attach to objects, child example extends parent example, so it inherits everything parent example has, including all of its inherited stuff from mono behavior. So I can now attach child example to an object just like I could parent example, because both of them are mono behaviors, because child example has everything parent example has. And I know that that is a mouthful, and I know that that is a lot of information to take in, but the clearest example that you can see of this is that I attached a child example object to an empty game object, and it inherited the name, class level, and health variables that are only in the parent example, not in the child example. So you can kind of see how this is going to be good, how this is going to start to allow me to do some interesting things, like say child example is going to have another variable called public string player name, and it's going to equal new player. So now child example has a variable as well as parent example having several variables. So when we go back into here, what we should see is all of the parent example variables as well as the child example variable at the bottom. So here's a practical example of this. And I'm just going to explain. I might not actually type it out. No, you know what? I'm gonna do it. Alright, so what we're gonna do here is we're gonna create a new C# object. You can just follow along with, you don't have to follow along with this like doing it, just try to follow along visually and understanding wise. So we're going to create a new C# object called ship base. And in this object we are going to extend mono behavior. We're going to use the start and update functions eventually, but what we're going to do is we're going to say public string name. It's going to equal a new ship, and then we're going to say public int health equals 100, and that is oh no, we're also going to do a public float speed, and it's going to equal I don't know, 4f, because I like 4f for speed for some reason. Public vector, vector 3, forward direction, sure, equals vector 3 dot forward. And so what we're creating here is we're creating a class that is going to be the root of every ship in a space game, right? It's going to be the ship that is going, well, it's going to be so broad that all of the variables on it, every ship in the game has, if that makes sense at all. So every ship in the game is going to have a name. It's going to have health. It's going to have speed. It's going to have a forward direction. Every ship is going to have that in our game. So some things that it also might have, say public void damage. That takes in a, for now, it's going to take in an int. That is the damage. Now we've kind of seen this in the previous videos. This is going to eventually change to accept a class that's going to have a bunch of other stuff in it. But for now, and this works. Health minus equals damage. And there's a better way to do this that I can cover in a later video. Well, I'm just gonna do it, and if you can follow along, consider yourself golden. So health is actually going to equal mathf dot see, and I already don't know what I'm doing, clamp, and we're going to say the value is going to be health minus damage, and then the minimum is going to be 0, and the max is going to be 100. So there we go. So if you can follow that, if you can read that, you're good. If you've just been following along with my series, I haven't talked about any of the mathf functions yet. They're pretty handy. I suggest digging into some of the Unity documentation. Look at that. See how I brought it full circle? Anyway, so we have our damage variable that's public, so anything can access it, and it's on our ship base, which means every single ship in our game can take damage. We might want to do like a whole, you know, if health is less than or equal to 0, which if you know what the above thing is, you know part of that is just superfluous and just a safety net. Anyway, then we want to do a kill function, just like we have done in the past with other things. Public void kill, and we're going to say destroy game object. Boom, like that. So now we have our damage all set up and everything, and we have all these variables. Great, perfect. So now we're going to create a new thing. No scripting errors, yay. We're going to create a new thing that's going to be called playership. Oh, oops, I don't want the H in that to be capitalized because that would be annoying. And now playership is going to, so I have to change it here as well, is going to extend ship base. See how it auto-completes? And now ship base, or playership, doesn't come with any of these start or update functions. It can, it will access them, but there is a conflict because it already has them. That would effectively leaving those in, leaving it like this, is the exact same thing as putting it in here twice, which isn't really allowed. If I do, well, I'm gonna get rid of these first. If I do that, it'll actually come up with an error. It says, hey, this is already a thing, you can't have two of them, you're crazy. Effectively, that's what we'd be doing by leaving it into the child as well, because the child, which is the ship, the player ship, this is the parent. This is the parent, by the way, ship base, and player ship is the child of ship base. That's what the parental hierarchy extension thing is that I was talking about earlier. So if we had left start in the child, it already has a start that's given to it from the parent. So it would effectively have two of them. The interesting thing is, though, the start function on playership would be the one that would be called if either of them are at all. Because oftentimes when you have the same class on a parent and a child, the child class overrides the parent class. There are ways to set that up purposefully with override classes that I might be able to talk about in a later video. For now, it's not too pertinent, but there are ways to purposefully set that system up, but the accidental way to set it up is to just leave the start and update functions on this thing. Leave them on the parent and the child. Not entirely a bad thing, just something you usually want to avoid. There are ways of causing this class here to call things in this class here, but they're not always the best, I guess. I don't know. Depends on how you look at things, but I feel that they're not the best sometimes. Anyway, so we have our player ship, and our player ship is going to have a, I don't know, what should our player ship have that nothing else has? Let's do a public int health regen of 1 and public int health regen time of 1. So effectively what this is, what I'm implying with this, I'm not going to set the whole thing up because it's annoying. It's going to take longer than I need to, and you guys should know how to do that. Is that every 1 second I'm going to regain 1 point of health. So yeah, that's basically what that is. So if we come back into here, 1 can't be, what? Constant value of 1 can't be converted to an int. Really now? What are you saying to me? Where? Oh! Ha! Oops. You're right. A float can't be an int. Okay. So now that that's done, So in our game object here, we have our child example, and it comes with the stuff for the child example. Whoops, remove player ship. Comes with all of the things that the ship base, which is this. So you can notice, you also notice that we can attach individual parts of things, so we can kind of snub that hierarchy wherever we want by just having it in a scripting in its own scripting file and dragging and dropping it onto a thing. So we can have the ship base as a thing that we can attach, and we can also have the player ship as a thing that we can attach. So we can have different levels of the hierarchy attached to different objects if we need to, which is kind of nice. You'll see that in some games and stuff, and some systems where the ship base is all you need for this object, so that's all we're going to have. And maybe the ship base is a good example of this, and this is going to sound weird at first, but maybe you put the ship base on a meteor because it has a speed, it has a forward direction, it has a health. That's all you need a meteor to have, really. I mean, if you just blow up the meteor by shooting it, it has the damage functions, it has all this stuff on it, so you might as well just use that. You just use the ship base. It won't have any functions as far as like being a ship is concerned, but it'll have all the variables and be able to interface with the ships just fine, just like every other ship. So that's kind of an example. Whereas, you know, your player ship is obviously going to interface with your input system and all of that jazz. And then maybe you have an enemy ship. Let's do that one. So we have a C#, we have an enemy ship. So our enemy ship is also going to extend a ship base, and it is not going to have any of this stuff. Instead, it's going to have a game object current target, and it's also going to have a I didn't make that public. There we go. It's going to have a public game object for shot prefab, just like we've seen in the past. And then inside of this would be all of our behavior for, you know, if the current target is within a certain distance or whatever, shoot at it. But the enemy ship is going to have a different set of stuff because we've assigned it a different set of stuff. It's going to have the target, the shot prefab. Much different than our player ship, which has a health regen, right? Because we don't need it to have an AI system for targeting and all that jazz. We do need it for this. So, but both of them have the name, health, speed, and forward direction. See how that's useful? So they both have everything the ship base has, but they have their own individual tweaks to that. And as such, they'll also have their own individual behaviors. The easiest example being the enemy ship is obviously going to have AI, whereas the player ship is going to need to be able to take its movement and stuff from a mouse and keyboard or game controller or whatever. So object-oriented programming is kind of a trip to get around. It can be hard to wrap your head around, but the benefit that you get out of it is so great. It's ungodly handy. If for no other reason, then you can keep everything organized and concise and clean, without, like, for example, if you didn't do this, if you didn't set up a ship base that has all your base ship functionality and then extend upon that, you would have to basically copy and paste a huge chunk of all of the stuff that every ship does into each type of ship, and then if you need to make a change to your ships, say that instead of health defaulting to 100, it needs to default to 50. Okay, I just did that, and now health defaults to 50 across all of my ships. It was that easy. I just changed the number to 50 and saved. If you had to copy and paste this between every type of ship, you would have to go in and manually change that number on every single ship, and that'll waste tons of time. On top of the fact that if you miss it, then suddenly you have a bug now because you just have to deal with this crappy system. But now the system, using extension and object-oriented programming, you can simplify that process and make things a lot easier for yourself. So hopefully this video wasn't too crazy. I know that it was kind of kind of conceptual, I guess. It's talking more about ideas than actually showing a fun example, but I hope it was helpful at the very least. I'm running out of ideas for videos. I mean, I have a whole list of stuff. Sorry, this is okay. We're done talking about object-oriented programming, and we're on to talking about the channel and stuff. I am kind of sort of running out of ideas. I have a list of things that I can talk about, but I would prefer to sit on those for a little while longer. I am asking you, what do you want me to talk about? Because I will talk about it. Do you want to see how to rig up a turret to shoot something? How about shoot the player? I can rig up a turret to shoot a player in no time. How about, I don't know, I can talk about the whole 2D side of Unity if you'd like. That's always fun. I can instead just drop the Unity tutorials altogether and switch to Maya if you'd like. That's always a fun thing to jump head first into. It'll hurt a lot, but I can do it. I can also talk about how to import meshes and talk about shaders and all that stuff. I might be able to do a really, really rough run through of Strumpy's shader editor, which is a third-party shader editor for Unity. That would be after I talked about materials and how to import meshes and get all your arts and stuff set up. But yeah, just please hit me up on Twitter and or in the comments and stuff, and let me know what you want to know. I'm here to help, and I'm trying to teach you guys what you want to be taught. Oh, I can also talk about sounds. Sounds is something I haven't talked about. Yeah, I just realized that. But if you have a specific scripting thing that you want to see, like a specific gameplay aspect, like I want to know how to make an AI move across NavMesh. That could be a fun, like, 3-video series. That'd be crazy. Done it. I know how to do it. Or if you want to see about, like I said, a turret shooting the player is pretty easy to do, and it's a lot of fun. Or like a homing missile, for example, that chases your cursor around the screen or whatever. Stuff like that is pretty easy to do, and it's fun. So yeah, let me know, and I guess that's everything. Thanks for watching. Bye-bye.